Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students working on the summative. It's practice question number 7. The question says, after a tee-off, a golf ball lands in a sand trap, 1 meter below the ground. The golfer hits the ball and it follows the function. So here's the function that we need to worry about, where h represents the height of the ball and t represents time in seconds. And what we need to do is we need to find the H and T intercepts, what they represent, how long is the ball below the ground, and how long is the ball above the ground. Okay. So let's start by making sure that we understand what the actual function is. So we know that we are talking about the height of a golf ball as a function of, oops, it looks like I crossed it out, as a function of time. So it's height here, and then time here. And so typically we have a golf ball that does this. So you hit the golf ball in the air, it flies up, and then eventually comes down. So we obviously have some sort of projectile here. I mean, if you've watched the other videos, you know that already. And then the other thing is that the equation is given to me in standard form, which means the information I have is in the form ax squared plus bx plus c. And that means that I'm going to have to do a lot of algebra here, because the only thing I can tell without doing any math is what the vertical intercept is, which is this number here. The constant term is the vertical intercept. And anything else I have to factor or complete the square or use the quadratic formula. So we'll see what we have to do here. And let's do that now. Let's look at what part A says. What do the H and T intercepts represent? So here I'm not actually doing any math. It didn't actually say find the H and T intercepts. It says what do they represent? So let's think about this parabola. So I sort of drew this picture already. We have a golf ball being flown in the air. Now, I'm not going to worry too much about finding math, but again, the one thing that I can do really quickly with a standard form is I can find a constant term. So, which means if I let t equals 0, so t is 0, t is 0, I'm left with this number. And that means that when the golf ball is at time equals 0, it has a height of -1. So, and I think that's sort of important in this case to have a look at that right now. Because what's happening here is that the golf ball is actually sitting, and I'm going to draw a sideways view of reality here. The golf ball is sitting below ground level, and then the golf player is trying to hit it out here. So that's why we have this -1 as the starting height of the ball. Again, I didn't do any math to find it. So it's important that you can look at that and understand that it's there for me, right? It didn't say to do math, and I haven't done math. I'm just looking at what I have. I have a starting height of -1. And then I don't know any other numbers right now, but let's make sure we understand what do the H and T intercepts represent. So now I have a reasonable idea of what's happening here. Let's look at, first of all, let's look at the H intercept. So this is the one I've primarily been discussing so far. The H intercept is right here. So the H intercept is where t equals 0. So what does it mean about the golf ball? So tell me, where is the golf ball, or what's happening to the golf ball in this situation? And then the T intercepts, well, there would be one right here and one right here. Now this one, we often will ask you to find this one. But make sure when you discuss what do the T intercepts represent, that there's 2 T intercepts in this question. A lot of projectiles only have one that's significant in reality. Oops. But this one, there's 2 T intercepts, and what do they mean, again, about the path of the golf ball? So that's what I'm going to want you to do in that question. And again, I'm not going to do the questions in this part of the video. That happens in the next part. How long is the ball below ground level to the nearest hundredth of a second? So again, think about the situation happening in this question. We have this. We have the golf ball being hit up out of a hole in the ground, effectively, a hole down a meter, and then up in the air until it hits the ground. So when it says how long is the ball below ground level, it's asking me how much time does it take for the ball to go from where it starts to right here, because the rest of its journey is above ground, right? Then it's up in the air, hits a maximum, and then hits the golf course somewhere here. So for this part, it's underground. Well, it's below ground, meaning 1 meter. And then how long, and then that's related to part C, which is how long is the ball above the ground. So I'm just going to go back since that's picture here already. This is the part where it's above the ground. So in order for me to answer those questions, how long is it below ground, what I've got in blue, and how long is it above ground, what's in red, if I can find the T intercepts, I'll know how long it's below and how long it's above. So really, every part of this question, if I go back to the very first slide, every part of A, B, and C requires me to understand the T intercepts. And obviously the H intercepts, but so it's sort of a different type of question than the one we saw before. So I hope that that is good enough for you to now stop the video or pause it, try to answer the questions on your own, and then come back and check your work. So press pause. Welcome back. So let's do this. So we have this height versus time parabola, and it says, what do the H and T intercepts represent? So you can answer this question without doing any math. So let's do that. So we know that the H intercept is -1. And then again, if we think about what's happening, it means that the ball is below ground in what's called a sand trap, and then it gets hit up in the air and lands down on the ground. So the H intercept, called the vertical intercept, right here, it represents the height of the ball when it was hit. So it's what height compared to ground level was the ball at the moment it was hit. So the moment it starts traveling along this parabola, where was it? It was down 1 meter in the sand trap. What about the T intercepts? Well, the T intercepts would be here and here. So the T intercepts. So one of them, so I'm just going to say T1 represents, let's call this one the first T intercept, T1. Oops, that looks like I wrote TI. Let's start wrapping some TI. T1. Okay. The first one represents the time when the ball was finally, I don't know why I need to put finally, was finally above ground level. I mean, actually, it's the time when the ball was at ground level. I don't think that's a big deal, but it's because time is a microsecond, so I don't know. Time when the ball was finally at ground level, because it started below ground level, it flew upwards, and at this moment in time, T1, it was at ground level. And then the second intercept, so T2, was the time when the ball hit the ground. Now, obviously I could have sort of said both of those things at the same time if I said that the T intercepts are the time when the ball is at ground level. And of course, what's interesting about this question is that normally we have a projectile motion question where the object starts on a building, on a cliff, whatever, and it goes up and down, and there's only one x-intercept. But in this case, we happen to have two, and they're both valid. So, okay, now I know this is terribly messy. Don't even look at it. But remember, I'm writing, you're listening to me. I'm just writing, so you have something to look at, I guess. So now the question says, how long is the ball below ground level? So how long is it below ground level? Again, what's happening is this little sketch here, boom, diddy boom. So below ground level is this amount of time, from 0 until whenever time that is. So I need to find where is the height equal to 0, and that'll help me figure out what the time is right here. So I'm going to let the height equal 0. And then we have a quadratic in standard form. So I'm going to use the quadratic equation. So t equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And then subbing in, so negative b plus or minus square root of b squared minus 4ac all divided by 2a. And then doing the math, so negative bracket 15 is just negative 15 plus or minus. 2 times negative 5 is negative 10. And now I'm going to get my calculator. 15 squared minus 4 times negative 5 times negative 1 equals, take the square root of that, 14.3. So I say it out loud just to help you in case you're having, you think you did everything right, but you get the wrong answer. It's amazing how often students get the wrong answer just because they're not comfortable enough with their calculator. And that's why I get really grumpy in September when I don't see you with your calculator every day, because holy cow, it's so important. Anyway, once I know that it was the square root of something and I got 14.3, now I have negative 15 plus and negative 15 minus, so I split into two different answers, one with plus, one with minus, and then I do two little separate pieces of math here. So negative 15 plus 14.3 equals, divided by negative 10. So I get 0.07, the James Bond time, and negative 15 minus 14.3 equals, divided by negative 10, so I get 2.93. Now, I'm really glad I saw both these numbers are positive, because, again, we expect that we should have two valid places, two valid times when the ball is above ground level. So one of them is really small, like 7/100ths of a second, and the other one is about 3 seconds, and that makes sense. So when it says, how long is the ball below ground? So it starts here below ground. It gets hit by the golfer, and it starts to move upwards, and then very quickly, really quickly, it's at ground level and moving up. So that must be the first time, 0.07, and then this one's obviously 2.93. So how long is the ball below ground level? The answer is 0.07 seconds. And then what about the answer to this one? How long is the ball above ground? So again, I'm going to draw this little picture. The ball is above ground for all of this time that I'm tracing out in red. And so we know that this is 2.93, but it starts off below ground, and it's not until 0.07 seconds that it gets to above ground. So I need to know how long it is in between these two numbers, which means I need to subtract 0.07 from 2.93, and that's 2.86. So the answer is that it is above the ground for 2.86 seconds. Because, again, the story of this golf ball is, hold on, okay. The story of the golf ball is that it's hit, it's below ground, and then it's hit, and in 0.07 seconds, it's now above ground. And then it continues traveling for 2.86 more seconds until it hits the ground. So in total is this 2.93 number. That's the total amount of time it flew, some of it below ground, some of it above ground. Okay, hope that was helpful. Happy studying.